All right, guys, section 3 of chapter 9, transformations of quadratic functions. So previously you graphed quadratic functions using the vertex and axis of symmetry. Now we're going to apply translations to quadratic functions and apply dilations and reflections to them as well. And we'll talk about what all that means. So that's just part of our vocab today: transformation, translation, dilation, reflection, something called vertex form. Pretty exciting, huh? All right, a transformation changes the position or size of a figure. You're transforming it, just like a transformer was a car and now it's kind of robot. All right, one transformation is called a translation, and it moves a figure up or down or left or right. When a constant k is added or subtracted from the parent function, the graph resulting is the graph of the parent function translated up or down. So this f of x plus or minus k means you're adding a number to the function or subtracting a number from the function. Okay? So the parent function of the family of quadratics is just x squared. That's as basic as you can get it. There's nothing multiplying it. There's nothing adding it. There's nothing subtracting it. It's just x squared. Okay, all other functions have graphs that are transformations of the graph of x squared. It's either moved to the left, right, up, or down, or it's changed the dilation or the reflection. We'll get into that later. All right, so the graph of f of x equals x squared plus k is the graph of x squared translated up or down k units. Basically, if k is being added, so if you have like plus k, it shifts it up. It just moves the whole graph up that many steps. If it's like plus 5, it moves it up 5 steps. If it's subtraction, basically just moves it down however many it says. So describe how the graph of each function is related to the graph of x squared. Well, these ones are pretty straightforward. X squared plus 3, what you're doing is you're adding 3 to everything that you do for x squared. So it's going to shift everything up 3 units. G of x is x squared minus 4 is part B. It's going to shift it down 4 units. It's going to move everything down 4 steps. Okay, so this one's up 3 units, and here's what the graph looks like. The green graph is the original function x squared, if you graphed it. X squared plus 3, or excuse me, I'm sorry, I missaid that. The blue graph is x squared. That's the original graph because it's at the origin. The y-intercept would be 0, and it opens upward. X squared plus 3 is shifted up 3 units. Now, it might look like the graph got a little thinner, but what actually happened is you're seeing more of the U on the blue graph than the green graph because the green graph is shifted up 3 units. Okay, in the G graph, it's going to shift it down 4 units. So here is g of x equals x squared minus 4 is the green graph. The blue one is just the parent function x squared. You can see it shifted down 4 units. Okay. All right. So here's a couple for you to try. Go ahead and pause the video. All right, we're back. So 1a is going to be the graph shifted down 7 units. So if here's x squared, x squared minus 7 is going to be like that. Okay, this one, just be careful. Make sure you write it in standard form first. So this would be x squared plus 5. So that's going to shift the graph of x squared up 5 units. So there's x squared. I'm just doing a rough graph here of it. And there's x squared plus 5. Part C. Make sure it's in standard form. You would actually rewrite that as x squared minus 5, and that's going to shift the graph of, here's x squared, it's going to shift it down 1, 2, 3, 4, 5 units to be like that. Okay? And then D is just the graph of x squared shifted up 1 unit. So here's x squared. And just shift it up 1 unit. There we go. Okie dokie. Pretty straightforward there. Okay, moving right along. Quadratic graphs can be translated horizontally by subtracting a term from x. Okay, so notice that This time, they're adding or subtracting a number in the parentheses, and they're squaring the parentheses, okay? Now, you can read this here, and it talks all about the absolute value and subtraction, and if it's greater than 0 or less than 0. Let me boil it down to you, okay? If you're adding or subtracting in the parentheses, it's going to move it left or right that many, but opposite the way you would think. So for the graph of x minus 2 quantity squared, it's going to shift it 2 units to the right, okay? X plus 1 quantity squared is going to shift it. So when it's added or subtracted in the parentheses, it's going to move it left or right, and it moves it opposite the way you would think. Normally, you think you add something that's going to move it forward to the right, or if you subtract something that's going to move it to the left, to the, backwards. But it's opposite the way you would think. So for g of x, I have the graph already produced here. So since it's x minus 2, it's going to shift it 2 units to the right. And there's our graph. The blue one is the original x squared, and it shifts it 2 units to the right. For this one, since it's plus 1, it's the opposite way, so it moves it 1 unit to the left. And here's the graph in blue of f of x, of just the parent function, and it just shifts it 1 unit to the left, okay? Here's a couple for you to figure out. Go ahead and pause the video. Okay, we're back. So 2a, here's the graph of x squared. Okay, since it's minus 3 inside the parentheses, it's going to shift it 3 units to the left. Or excuse me, 3 units to the right. Okay, for 2b, here's x squared again. And since it's plus 2 inside the parentheses, it moves it opposite the way you would think. So it's 2 units to the left. Boom. There we go there. Okie dokie. All right, quadratic graphs can be translated both horizontally and vertically. I mean, you can move it left and up, or right and up, or left and down, or right and down, okay? So you just have both of those in there at once. So if you look at g, it's g of x equals the parentheses x minus 3 squared plus 2. So remember, when it's inside the parentheses, you're adding or subtracting. It moves it left or right, the opposite way you would think. When you're adding or subtracting outside, it moves it up or down that many units, okay? So this one, it's going to move 3 units to the right and 2 units up. So here's the graph of f. So it moves 3 units to the right and 2 units up, and then you put the graph there. Okay, this one, it's going to move it 3 units to the left and 1 unit down. So the blue graph is here. 3 units to the left and 1 unit down is where the vertex is going to be. And then you just redraw the parabola from that point. Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So 3a, we're going to move it to the left 2 units and up 3. So here's the graph of x squared. So we're going to move it to the left 2 units, down 3. I like to put a little point and then make my parabola there. This one is going to move it to the right 4 and down 4. Okay, remember, in the parentheses, it's left or right, opposite the way you think. If it's outside the parentheses, it's up or down the way you would think. Okay, so here's my original parabola. Move it 1, 2, 3, 4. 1, 2, 3, 4. Put a point. So 4 to the right, 4 down, and then put your parabola there. Okay, again, I'm just rough sketching it. You can get more accurate if you want there. Okay, well, that's it for vertical and horizontal translations. In the next video, we're going to talk about dilations and reflections. All right, see you there.